In this video, I wanted to talk about the concepts of domain and range. Now, domain and range are basically talking about how far a graph can go in the x direction, so just in the horizontal direction, or how far it can go in the y direction, or just the vertical direction. So the x direction is referred to as the domain, and the vertical direction, the y direction, is referred to as the range. Okay, so I'm going to do this graphically, not using algebra or by resolving equations, just because it's a little bit easier to explain that way, and also it's a little bit shorter. So let's see, if you watch this video and find that it would be helpful to see an example using just an equation, then just throw a comment in the comment box, and I'd be happy to make one for you. Okay, so let's say, for instance, we have basically, let's say, a graph that just looks like this, and we'll use a purple line in this case. Okay, so any graph can look like this. Okay, and there's an arrow on both sides, and basically what this means is keeps going on in both directions. Now, what we would say then is that the domain was that x is an element of R. Okay, now what this means, okay, is that x, okay, so this is the variable, okay, this means element of, or means it's a part of, okay, or it belongs to, and this means the R means the real numbers. Okay, so what we can say is that the domain is that x is an element of R, and for the range, so sorry, this is domain, okay, and for range, we can say that y, in this case, is also an element of R. Okay, so both x and y are elements of R. And the reason why is because they go to infinity, so negative infinity to positive infinity in both directions, and they also include all of the values in between, like every whole number. So every value from negative infinity to positive infinity, which is all the real numbers. Okay, let's go do something a little more complicated. I'm going to have to go and undo this all to get rid of this old graph. Okay, and I'll just have to reload this one. Okay, so let's say, for instance, I have another graph, okay, and it looked something like this. Okay. Now, what this would mean, okay, what this little dot here means is that x starts here, okay, and y starts here. Okay, it does not. It also includes this point and moves off in this direction into infinity. Okay, now in this case, it's a little more complicated, and the way we describe this, so the domain, we would say is now I'm gonna have to introduce some new notation here. Now the first thing is the curly braces. Okay, now curly braces, I'll actually write these over here. Okay, the curly braces means a set. Okay, it means that we're going to talk about a set. Okay, a vertical line, okay, means such that. Alright, and as I said before, this E means element of. Okay, so what we're going to do is open up a set, and we're going to say we have x such that x is greater than or equal to, and we have this value 2, comma, and then because the reason why we're saying this is because we can see that x starts at 2 and moves, and it includes all the values that are greater than 2, and x is an element of the real numbers. Okay, and we close the set with another curly brace. Okay, in this case, y also starts at 2. Okay, so the range, okay, would be that y such that y is greater than or equal to 2, and that y is an element also of the real numbers. Okay, so that's kind of how that works. I'm going to show you two more examples. Okay, so Cartesian, I have to create a new one. Cartesian grid. Okay, so I'll show you another one here. A very similar one. And what we'll have is one that maybe goes like this. Use one going in the other direction. Okay, so maybe something like this. Now, what often mathematicians use a open circle for is to say that the graph starts here, but it doesn't actually include this point. Okay, so it starts like right after this point. So in this case, the domain starts really at x is equal to 2, but does not include x equals 2, so it's everything bigger. So we would say that the domain, in this case, is a set, okay, that includes x such that x is greater than 2. Now, keep in mind, it did not say x is greater than or equal to 2, just greater than 2, comma, and x is an element of the real numbers. Okay, and in this case, the range is a set, okay, including of y, such that y is, let's see, is 1, 2, 3, 4. Y is less than 4. Now, not less than or equal to, because it doesn't include this point. And y is an element of the real numbers again. Okay, now these are for continuous values, but what about discrete values? Okay, so let's say, for instance, we had a graph that just looked like this. Okay, now this is a graph where y is equal, let's say y is equal to x or something like that. Okay, for a certain area. Now this one's a little bit trickier. Okay, so what would the domain here be? Okay, well, the domain is a set of x such that, let's see, x is greater than, or we'll say 1 is less than or equal to x, which is less than or equal to, let's see, 1, 2, 3, 4, 5. Okay, so 5. Okay, now when I just say that x is greater than 1 and less than 5, now what this means is that it's going to be in there, but if you just say this, it implies that it includes all of the values, so like 1.5 and 2.5 and 1.5 or 1.55 and 1.8 and basically every number in between, which is an infinite number of numbers. But it doesn't. They only include these specific discrete points. So what we have to do is we have to clarify and say that x is an element of the natural numbers. Okay, so now x is only the natural numbers, which doesn't include any of the decimal values. Okay, similarly, for the range, okay, we can say the same thing. Y is a set such that y is less than or is greater than or equal to 1, also less than or equal to 5, such that y is an element also of the natural number set. Okay, now that's pretty much it for domain and range. And what we're really doing is just saying how far does this go, and then basically how much like how much does it go in the x direction, how much does it go in the y direction. There's some uses for this, and sometimes sometimes it's not really apparent. But really, a lot of times what we want to do is just examine just a section of the graph. And so, as I said in one of my previous videos, sometimes the graphs exhibit weird behavior, especially when the numbers get really big or really small. So when we have a given phenomena, what it could be is that the graph is representative of that phenomena, but only within a certain range. So we might specify the range and domain, saying that this is only a representative of this model from here to here and also from here to here. Right? So anyways, hopefully this helps. If you have any questions, then please drop me a line, send me an email, put a comment in the comment box. If you like the video, please give me a thumbs up, and if you like my channel, then please subscribe.